Hello everyone, my name is Andrew, today we continue learning Python, and today I'll show you my new library that will allow you to write the best patterns without ever implementing them. So let's start. So I talked about patterns a lot, and in the last 3 months I had to implement like 20, maybe 40 patterns myself. But the thing is that I implemented not 40 different patterns, but all of them were the same. It's kind of like I had one pattern like singleton and I had to copy it from one place to another. I had a repository, a unit of work, and I had to copy it from one project to another. So I decided to create a library that will allow you and all the other people to create those patterns in Python without ever implementing them. So once again, that's a library. It's called Assimilator, so PyAssimilator. You can go to PyPy, the link is in the description. You can also go to GitHub. You can look at it, but the library is actively developing, so you can use it, and I already use it in my projects, but the thing is that it can change. So make sure that you can change the library once it changes. So yeah, it's developing, that's all you need to know. And today I will show you how that library works with SQL Alchemy and databases, because I'm gonna have lots of patterns in there, but the main pattern that I want to implement, or the main type of patterns that I want to implement, are domain-driven design patterns. Because domain-driven design is a really good thing, if you can use it right. So if you don't know about anything about domain-driven design, I have lots of videos on repositories, unit of works, entities, and all that stuff. But the thing is that domain-driven design is often implemented in languages like C#, Java, let's say any other language. But in Python, it's kind of hard to implement it, because we have lots of libraries that were built using something else, so not the domain-driven design, and I want to bring domain-driven design in Python. That's why I created that library. So once again, there are going to be lots of patterns, so you can go, I work in feature/events branch right now, so if you go here, you are going to see that I have Redis, Kafka, internal patterns, Alchemy patterns, and all that stuff. But the thing that I want to show you right now is what my library is all about. And I'm going to show you that with two patterns. The first pattern is going to be called Alchemy repository, and the second one, Alchemy unit of work. So what is a repository and what is a unit of work? Repository is a pattern. I explained it, and I don't know if I'm going to remember that, but I hope that the video is going to pop up somewhere. I think somewhere it's going to pop up, and the video is going to explain what is a repository. But and also I have a video that talks about unit of work. So if you want to watch them, watch them. But if you don't know what is a repository or unit of work, I'm going to explain it briefly. Repository is a pattern that allows you to kind of virtualize your database. So imagine that instead of using SQL queries, instead of using some hard things that will not allow us to change the databases quickly. So if I want to go from SQL to MongoDB, for example, or from SQL to Redis, I'm not going to be able to do that if I have SQL queries all over my code. And repository, not Alchemy repository, because Alchemy repository is related to SQL Alchemy, a library for SQL communication, but or for database communication with SQL. But repository is a pattern that allows you to kind of abstract your database and only use the class itself, so repository class itself, as a virtual collection. So imagine that you have a list or some kind of virtual collection in your system. Alchemy repository, or any repository, makes it so that your collection or your code does not know how we save the things, how we update the things, how we delete the things. It just knows that we can update, delete, and do all that stuff. So let me give you an example. And yeah, one important thing is that I create all my dependencies in a dependencies.py file. So let me go to main.py, and I'm going to show you how all that works. So let's say that we want to use getUser function. Let's say that we want to get our user. And yeah, the model that I'm going to use for that, it's an SQL Alchemy model. It's pretty simple. So we create an engine, we create sessions for the database, we create our declarative base. If you know SQL Alchemy, you know what all of that means. But if you don't, we just create a simple table in the database. We have ID as a primary key, username as a string, and email as a string. And then I also have an str function that allows us to convert our user instance to a string, kind of like that. And that function is used right here. And also we create all the tables in our database. So a simple table with ID, username, and email. And let's say that I want to query my user by its ID. What can I do? I go to getUser function. GetUser is a service function. It's our it's a query, it's a function that contains all the logic that we need, and I have lots of videos on those as well. But that function has two things. The first one is the ID that I want to query with, so the ID that I want to look for, and then the repository. Repository is passed as an argument. That is really, really important, and all of that is going to be explained a little bit later. And then what I do is I just call repository.filter. I do not know that I talk to an SQL database. I do not know that I talk to some kind of a specific data storage, but the only thing that I know is that if I call repository.filter, I'm gonna either receive a user or get an error if that user does not exist. Or sorry, repository.filter, yeah, it actually should be get. So get and filter. I'm gonna explain what's the difference a little bit later. But I'm either gonna receive a user or get an error because the user does not exist. And that's how repositories work. And now let's take a deeper look into how all that works. So I'm gonna go to the base repository. It's not an SQL Alchemy repository, it's just the base repository, like the very, very, very basic repository. It's an abstract class, so we can't really use it directly, but I can use it in annotations. So kind of to show that my repository is a base repository. So what do we have here is we have, well, a lot of things, but the most important thing is session, initial query, and specifications. So session is your data source. Session in your repository is your data source. It works kind of like, well, it's your data source. I have nothing else to say. So it's your MongoDB connection, it's your MySQL connection, it's your, I don't know, API session if you want to use some other API as a database. It's your connection, it's your data storage. And then you go with initial query. Initial query, it can be none, and the function that is used is get initial query. The thing is that when we filter or query any data from the database, we want that initial query. But why do we want it? Because we have a function called apply specifications. So what's that? Okay, get initial query, apply specifications, that's kind of a lot. But the thing is that we want to use our repository as an abstract thing. We don't want to say, okay, I use SQL, or okay, I use MongoDB, or I use NoSQL, or I use something else. We want our repository to be abstract. But the thing is that sometimes we want to query our data with different parameters. So we want to query our data with ID. Maybe I want to query my user with its username or email and all that stuff. Maybe we want to join some tables together. Maybe we want to order some tables by, I don't know, by their email or by the date that the user joined, but the date when the user joined our project or something like that. So when the user was added to the database. Maybe we want to do all that stuff. But the thing is that the repository is a very abstract concept. It's a very abstract class. So we can't really put all the filters, all the things inside of our repository. And that's why we use an additional pattern called specification. So let's go to specification and I'll explain what that is. Of course, I have a specification like that. So it's a function or a class. You can choose whatever you like. But basically, specification is a stateless class. So that means that it does not save anything. So yeah, kind of like that. Does not save anything. It's a stateless class that allows you to specify what you want to do with your query. So let's say that we want to query our users from an SQL database. The query that is going to be an initial query. So let me remind you that we have an initial query. Initial query is the basic query that is, well, that you have. It's like the basic query. What's going to happen? Initial query is going to be something like select all from users. Like this. Select all from users. But maybe we want to filter our users with their ID. And that's when we use specifications. So what do we have inside of that specification? We have a function called apply and also a function called call. If you don't know what call is basically when you can have an object, use parentheses, and kind of call an object as a function. So I'm going to show you a little bit later where that is used. But we have a function called apply or a decorator, and I'm going to show you how that's used as well. And what does specification do? Specification tells us specific things, or specification specifies our query. So we can not just say select all from users. We can say select all from users where let's say ID is 1. Like that. So specification adds that where ID is 1. Or it may add order by username. Something like that. So specifications specify our query. They can even say select email. Maybe we only want to select an email of a user who has ID 1 and we want to, for some reason, order it by username. I don't know why, but maybe we want to do that. All that stuff can be done with specifications. And the only two places where you're going to have your SQL query or any kind of data storage queries, because that not only works with SQL Alchemy, that works with MongoDB, with any other thing. You just need to write the repository yourself. The only two places where you're going to have your data logic or your data storage logic or your data aware logic, your queries, all that stuff, your mutations is repository and specifications. So what you're going to do, you're going to write repository. If you need one, of course, you have repositories like for Redis, for internal use. So repository with a dictionary inside of it. You can have Alchemy repository. I'm going to add a lot more, but you can add your own repository with base repository class, and you can add your own specifications that will kind of extend your query. So say what you need, how you need it, and where you need it. That's the thing. Then we can go to how our specifications work. So, okay, how do we extend that? The thing is that each specification is a thing that, well, we have apply function, and each function or each specification calls apply. So we have function called apply specifications, and that function is called in get and filter, or at least it should be called in get and filter. Those functions are not implemented, but I'm going to show you that in an Alchemy repository. So what we do is we get our initial query with the get initial query function, so kind of like that, and then what we do is we go through each specification and we update our query with that specification. So as you can see, we say specification parentheses, and since we have call already decorator, so that call function allows us to use both functions and classes or objects in specifications. So both specification objects and decorated functions. And how does it work? We call each specification, and each specification returns a new updated query that has more filters, that has more things inside of it, and each specification adds something to the query. Then, after we've done with that, we return the query. And the only thing that we need to do after that is execute that query. That's it. So we apply specifications, we specify what we want to have in our query. After we get our initial query, so we get the initial query, specify what we want, and then return the query after that. And that's it. That's the only thing that we need to do in order to make any kinds of requests with the repository. And the beautiful thing is that if you want to make a repository that works with SQL Alchemy, you can make an SQL Alchemy repository. So you can import it in my case, because I already have it in my Assimilator library. Or what you can do, well, you have to make the Alchemy repository, and then you have to make the specifications. And that's it. That's the only thing that you need to do in order to query any kind of data. If you want to make a repository that works with MongoDB, you have to make a repository for MongoDB, make specifications for MongoDB. That's it. That's the only thing that you need in order to query any kind of data. And the beautiful thing about repository is that they can be really, really, really quickly changed, because repositories do not have any additional functions. So you should not really create any additional functions that are going to be directly used. What do I mean by that? If you have a repository for your user, because you can have like user repository, you have, let's say, balance repository, you have order repository. So repositories typically work with one big entity. So one big thing that exists by itself, like a user or an order or a product or something like that. And but yeah, I explained all that in the repository lecture. Right now I'm just showing you how the pattern works. So we have get and filter, and the thing about patterns is the thing about base repository is that you don't want to add any additional functions. So you don't want to add get user by ID if your repository works with a user. And the beauty is that if you don't do that, what you can do is just replace the repository when you need, and we will change our data storage very easily. So what do I mean by that? If we have two data storages for users, let's say we have MongoDB and SQL Alchemy. The only thing that I'm going to have to change in my getUser function is the repository that I put in my variable and the specification that I put in my repository. That's it. That's the only thing that you need to do. And everything else will work just fine. So that's it. That's kind of how repository works. Now, let's go and look at other functions. So the main three functions that we're going to use today are get, filter, and save. We have refresh, is modified, update, delete. So most of them are going to be explained in the documentation or in the videos that I'm going to do next, because I'm going to have lots of videos on that library, because I think that it really helps you because I use that library personally and I don't spend any time implementing those patterns. So get function just gets you one thing. Well, one thing. So as you can see, we have specifications and also lazy. Lazy is the kind of query that is not executed right when it's called. So that means like lazy, well, we don't want to execute that query right now because we can have some memory issues or something like that. So we want to just build the query, but do not make it. So do not make the query to the database or to the data storage, to the API or wherever. And we also have a filter function. Filter function returns lots, so a lot of entities. So if we have get function, I get one user. If I have filter, we get many users. Kind of like that. So that's the only thing that you need to know. And also save function. Save just gets an object that we need to save and saves that object. That's it. Now let's go to the Alchemy repository and you'll know how everything works, and it's going to be really, really clear. Because all the things that I told you about are really, really, really abstract. But if you go to Alchemy repository, what you can see here is that we have a very, 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 well, a structure that went from base repository to Alchemy repository. But the thing is that we have get and filter implemented here. And if you look at it, what we do is we apply all the specifications. So with the apply specifications function, if that's a lazy request, that means that, well, apply specifications is the query that we build with all the specifications. If that's a lazy request, we don't want to execute it right away, so we just return it. Or else we return, or else we execute the query with self-session execute, and we return one result from our database. So one user, one order, one product, or anything else. We also have some accept and erase functions, but it doesn't matter right now. We also have filter and save. The only thing that save does is self-session add. If you worked with SQL Alchemy before, you know what that does. But basically, we add an object to the session so that we can save it later. That's it. So we have save, refresh, delete, is modified, and all that stuff. And the thing is that the only thing that you need to do in order to work with an Alchemy database, so with SQL Alchemy, is just create that repository, have a session, so add a session that is going to be used to communicate with the database, add an initial query. As you can see, my initial query is just a select from an SQL Alchemy, so select user, that's it. And then what you have to do is just create an Alchemy unit of work. But you can work with repository only. But unit of work is another pattern that is used in order to work with the session. So repository works with the data, but unit of work is, well, it's much simpler, but unit of work is a pattern that creates transactions. That's it. So the only thing that we have in unit of work is begin, rollback, close, and commit. I'm not going to show you unit of work, which is like, well, the most basic unit of work, because you have lots of functions here. But what you need to know is that you want to use unit of work with every request that changes your data. So if you have a mutation, so something that changes your data, you want to use unit of work. That's it. That's just the rule. You also have begin, rollback, close, and commit functions. Begin starts your transaction. Rollback, well, it deletes all the changes that you've done within your transaction. If you have an exception, close closes your session, so just close the connection or close the transaction. And commit commits your transaction, so states that okay, the changes are good, the changes are integrated into the database, so they are saved, kind of like that. And why do we need Alchemy unit of work? Because the thing is that when we want to work with data mutations, we need to have transactions. So transaction is a really, really important stuff. And let's look at create user function. So I'm going to comment out update users, but let's look at create user function. So what we do here is we provide our unit of work. I created in dependencies, and the unit of work gets a repository inside of it. So repository goes inside of unit of work. And here's the thing. The thing is that if you look at main, create user here has well, ID, username, email, and unit of work as the last argument. And what we do in order to create a transaction is we just say with UOV. I'm pretty sure you've seen those context managers. That's what it's called, context manager, with files or with some other libraries like AO HTTP or requests. But what it does is that with UOV starts your transaction. Then you can make any kind of changes that you want. So I have 2 users right now. I create 2 users. Then what you say is uov.repository. So remember that you have a repository inside of your unit of work. So you pass it as an argument. Then you can access that repository with uov.repository. And you can call a function save. uov repository save, uov repository save. And then you're saying, okay, everything's good, uov commit. What does it mean? We create two users, we add them to the session, so to the repository, and then we commit our data. And that's it. But what does it do for us? The thing is that if we save the first user, let's say that we need to save both users for our database to properly work. So let's say that we're creating a chatbot, or a chat, and we want both users to talk to each other. If we can only save one user in the database, that means that our data is inconsistent, and that is really, really bad because the program is going to break. So we want our data to be consistent. But the problem is that if we only save one user in the database, and the other user is gonna, it's gonna have an error. So let's say that email, we have the same email here, but let's say that email should be unique. If we only save the first user, but forget about the second one, so let's say that we save the first user, but forget about the second one, or we don't forget, but the second user gives us an error. So user 2 gives us an error. The thing is that our UOV will not allow any changes to persist or to be persisted. UOV will automatically roll back your transaction, because remember, we have a rollback function here, session rollback, and none of the changes that you applied, none of the changes that you made are going to be applied to your database or to your data storage. And why is it so important? It is very, very important because you want to have transactions. I have a separate video on SQL transactions, how all that works, so go and watch it. But the main idea is that if you have any kind of error within your unit of work, it's going to give you, nothing is going to be persistent. Your error is going to be, or you're not going to have inconsistencies in your data. So everything will be rolled back. And the thing is that if you want to commit your data, what you have to do is just write uov.commit. So what I'm doing here is I'm creating two users, I add them to the repository, and then I'm writing uov commit. And I create those users with my patterns. Okay, that's how all of that works. And you don't really need to know all of that for you to work with my Assimilator library. But the thing is that the only thing that you want to know is that how the patterns work and where do we need them. Because yeah, it's going to be really easy for you to implement anything with my patterns. Because what you need to do in order to implement an Alchemy pattern or Alchemy repository and Alchemy unit of work, just need to create a repository variable. So repository, so Alchemy repository, pass a session to your database, then create an initial query to your user, to your order, or to any entity in your database, and then create an Alchemy unit of work. And then that's actually it. You just use that Alchemy unit of work. Here I imported from Alchemy dependencies. You just use that unit of work, and the only thing that you need to do is with UOV. So with unit of work, do something. UOV repository filter, get all the users. As you can see, we don't have any specifications, and our initial query is select all from users. So we select all the users in our database. Select all the users from the database. With UOV, get the user with ID, and then delete that user. We use an Alchemy filter specification here, and what it does, I didn't show you that, but what Alchemy specification does here, or Alchemy filter, sorry, we have Alchemy specifications, but it just shows us that we need to use queries and return queries if we want to create any specification. But what we have here is that Alchemy filter is a specification. So we're saying repository get ID, Alchemy filter, and Alchemy filter just gets all the filters, so filter and filter, and then uses query.filter.filter by. Those are the functions, filter and filter by, from the SQL Alchemy library. So the only thing that you are doing here is we're saying, okay, we have that query, and you need to update that query and return a new updated version. So query.filter from all the filters, filter by from all the filters. Those functions work a little bit differently, so you can use any of them. But we're saying, okay, return a query with a filter and filter by. Boom, our query is returned. So we're saying ID is ID, or I can say anything that I want. Username is Andre, or I don't know, let's say ho, something like that. And it's going to use ID as ID, username as ho, and it's going to search for that specific user. If it does not find anything, we get an error. Nothing is saved because we have a UOV, and if an error occurs within our unit of work, everything is rolled back. If everything is good, we're saying, okay, repository delete the user, committed, that's it. And the thing is that repositories are really, really easy to replace. I just want to show you how I work with internal repository, or I think it's Redis. Yeah, I think it's Redis. And you're going to see that nothing really changes. Nothing changes. Of course, I have a different logic here because I have a balance for the user. I have username and mail, and I put them here. But if you look at the functions, nothing really changes, and everything works perfectly fine. The only two things that change is the dependency that I have. So Redis repository and the Redis unit of work, because we work with Redis. It's a database in the memory. And the other thing that changes is the specifications that we use. So I use key specification here because, of course, Redis doesn't have any SQL filters as my filter Alchemy specification does. So that's just it. Repositories and unit of works are really, really easy to use, and I hope you're gonna find my library really, really, really useful for your projects. So that's it. The only thing that you need to know right now is that I have that library. You can download it right now, once again. So if you go to, project PyAssimilator right here, you're gonna see that it's still in kind of like beta, so I'm still developing it. But you can use it right now and it's gonna work. Well, it's gonna work. I hope so. I'm not saying that it will, but it works in my project, so I think that's fine. Download that library. If you have any ideas, if you have anything to say about that library, about that module, if you have any additions, if you have any improvements, write them down in the comments, write them in my GitHub, contact me, or make a pull request on GitHub. So do something about it. Thank you for watching. You can use those patterns. They are fully domain-driven design approved, if I can say it like that. And yeah, that's kind of it. Thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment, download my library, and bye-bye.